Alright, pretty excited to start this video segment. We're going to take a look at productionizing our data ingestion system through a combination of Cloud Run and Compute Engine. Technically, you can run this ingestion system purely on Cloud Run, but we're going to add in an extra layer just for fun, because why not? But I'll just give you a rundown of how that's going to look like. So we have our ingestion job, which is going to generate a HTTP post trigger, and that's going to initialize our VM starter job on Cloud Run. It's going to pull a Docker image that we've built into Artifact Registry, and that is going to generate a virtual machine compute instance, which is going to pull in a separate Docker image, and that second Docker image is going to contain the Python scripts for executing our data ingestion. So making requests to the chess.com API, pulling in that data and loading it into GCS. So yeah, it's pretty simple stuff. So we're going to take a look at, let's take a look at our Cloud Run functions. So we're just going to dip into that real quick. So let's go into our Cloud Run function. It's called VM start. And this is the set of scripts that we have running. So we've got a main Python file and we've got a VM initializer script. And I'll go into those things individually to explain what's happening. So first we'll dive into our Python file, and we can go straight into our main function. And we can see we're pulling in our credentials from a service account that we've attached to this job. And that will help us authenticate with the Google API to do our logging. And that's going to help fire off logs into our GCP environment. But the main process of this script is actually here. We're reading in this VM Initializer shell script, and that contains all of the gcloud commands for creating our virtual machine instance. So you can see here we got this script runner variable, and it's running a bash subshell. We're going to read that script and we're just going to execute it, and that's all there is to this Python script. The only reason why it exists is because Cloud Functions needs some kind of Python runtime. I'm not sure if you could run a container purely on bash, so that's why we have the Python here. The Python is simply just to run the bash script underneath the hood. So we're going to go into our VM initializer just to see what's happening, and we can see we are declaring all of our variables. So we've got our project ID, our instance name, the machine type, our VPC, and we're going to plug all of those variables into our gcloud command, and that's going to build up our configuration for creating a virtual machine to run our to run our pipeline. And that's all there is to it. We've also got our container image, this chess ingestion processor. This is the image that's going to contain the Python script that's going to be making requests to the chess.com API. And that's all there is to this cloud function. Its only purpose is to initialize a virtual machine. So what do we need? We need a Docker image to package this initialization script so we can serve it onto Cloud Run. So we can go into the place where we set that all up, and I believe we save it somewhere here. So we got this VM starter directory housing our Docker files. We've got a Docker file and we've got a variables file. I'll quickly go into the variables file to show you what's going on in there. And essentially it's setting all of the parameters for defining Docker image names, container names, and configuration specific to artifact registry. And this is a way to help you plug these things into your Docker scripts in order to have a reproducible configuration when you're doing Docker builds between various projects. And I'll show you the Docker scripts in a second, but before we do that, we'll go into our Dockerfile. And I will show you how we are building our image. So we've got our base image coming from the Google SDK toolset to give us access to gcloud, BQ, GSUtil, etc. And we're changing to the bash shell because why not? And we're setting our working directory to the app directory, which is where we're going to be housing all of our scripts. And then with our package manager, we're going to run an update, and we're going to install a couple of packages, namely pip. We got git, we got curl to download files from our repository, and we got vim just in case you need to do some troubleshooting inside your container. You know, when things are going wrong or you need to test things, you're going to need some kind of text editor to do so. And I know you're looking at this and you're probably thinking, you know, why the hell are you curling files into your Docker image? And, you know, I totally agree, like, we shouldn't be doing this. But I'm just doing this for the purposes of getting this pipeline off the ground. Later, we will revise this and we'll set up a system for, you know, when we launch a container, we want it to download files from GCS into the container, into the relevant directories. But, you know, that's for like a future video. So we'll take a look at that at some point later in time. So we download all of our scripts and then we just pip install the requirements, and that's about it. We also need to specify this break system packages flag because the operating system doesn't allow you to install random packages onto the operating system. So we're just going to break the rule of, you know, making a virtual environment, since we're Dockerizing the entire image and it's got a singular purpose for just running a couple of scripts. I think it's okay that we're not using a virtual environment system. And yeah, after that, we simply set the entry point for our application. We're using Python to execute our main Python script, which under the hood is executing our shell script for instantiating our virtual machine. So there you have it. So there's our cloud function. We've also got our second Docker image. We got our chess ingestion processor, which is the one that's going to be doing all the API requests. We're going to go into the Dockerfile, and we can see we've got a very similar setup, same base image, also changing the shell to bash. The only difference here is we are making a few extra directories because we got a very specific file structure in Git that we also want to replicate. So we're making, in the apps directory, we're making an inputs directory, and we're making a functions directory where we're going to install all of our functions to run our main Python script, so we can import them. And then we just curl. Yeah, I know. We're curling everything. We're curling everything into those relevant directories, so we're able to execute this stuff. And we're installing the requirements, needed to execute that pipeline, and there you have it. You're good to go. You just run Python as the entry point and running your main Python script, and you're just running your API requests, and there you go. So you build your configuration for the Docker files. What you need to do at that point is you need to build your images locally. And in order to build the images locally, we need to create a series of Docker scripts. I'll quickly show you them here. So let's go into here, which is where I save all my custom Docker scripts. And we can go into our image build script, which is necessary for building our images. Yeah, so once you create your Dockerfile, you're going to execute a Docker build command. We're going to import all of these variables that we created earlier inside our directory. We're going to import them into that script, and you're going to build them into a specific image name. So you need an artifact registry. I'll show you side by side, in fact. You need an artifact registry like region, a repository name, you need a GCP project, and all of that needs to be structured in a specific way, so you're able to push it later on into artifact registry to the correct endpoint. And yeah, we can test out our build command. So let's run this. And we can see our Docker image is getting built up from scratch. We're just going to cancel that real quick. And so you have your Docker image, and you want to let's run that again. You want to push that into artifact registry. You can see the format of the image name right here. So we got our location, GCP project, repository name, and image name, plus the tag. So at that point, you need to push that into artifact registry. We have our command here. We've called it image push. So I'll quickly show you here. Image push. You're sourcing, you're sourcing all those variables from that directory you're in. And you're recreating the same image name structure, and you just Docker push it. You push it into artifact registry. So I'll give you, I'll show you what it looks like here. Image push, and since the hash of the image hasn't changed, it's not going to re-upload itself onto artifact registry. Artifact registry knows nothing has changed, so it's not going to re-upload itself. And yeah, I'll show you what it looks like once it's in artifact registry. So we can quickly go up here, go in here, and we can see we've got our Docker chest repository for housing Docker images. And we can see our Docker image for doing our virtual machine initialization. And we've got our Docker image for running our chest pipeline. So there you go. You can click into either one of them. You can see which images are pushed in and then what the tags are. And yeah, this is the primary way you're going to be managing those images on the GCP platform. So, you have your images on GCP. At that point, you need to instantiate your resources for putting those images into containers and executing them. So the way I've planned this out is we're using Terraform to build up our resources in order to execute put those images into containers and execute them. So let's get rid of this. Let's go back into our chess analysis repository, and let's go into our main TF file, which is for declaring what resources that we want built into our GCP platform. And we got a couple of blocks here underneath the VM Initialisation header. We can see that we've got a cloud run job resource, and we've got a cloud scheduler job resource. So within the cloud run job, we can see we're specifying the image that we want to execute within that specific container, which is the VM and the VM start. And we're also specifying the service account that needs to be attached in order to run the necessary with the necessary APIs. And we got our Cloud Scheduler job with the name declared here, what it's supposed to be doing, the schedule, which is once a month on the 3rd of the month on the 11th hour, and once that condition is fulfilled, it will target this HTTP endpoint and will submit a post request using this Google API, and it will be targeting our VM starter job and asking it to run, which it will force it to execute. Of course, we have to specify some authentication, so we're generating an authorization token using this service account email, which is conveniently named start VM, and yeah, that's going to help us get us off the ground. And then at that point, you can run your Terraform steps. You can, if you've made changes to your main.tf file, you just simply run Terraform plan, and you run your Terraform apply, and that's going to deploy your resources onto the cloud. But since nothing has changed in my Terraform configuration, nothing's going to happen. But at this point, we can go ahead, we're all set up. We can go ahead and jump into our Cloud Scheduler and attempt to execute our pipeline and see what's happening. So let's go into Cloud Scheduler. And we can see that our scheduler job has been created. We're already past the time frame that it's supposed to execute. But what we can go ahead and do is we can just select it and hit force run, which will artificially force that post trigger to occur, and it will trigger our cloud run job. So we can go into our cloud function now, just to observe what is happening. We can go to jobs, and we can see our VM starter job is actually running. So we can actually click into this and just monitor what's happening. You can go for the logs if you want and see what's being triggered, what's being loaded up. We can see things are initializing. Well, that might have been from a previous run. I think here it's reading the initializer script. But we'll go back one step, and we'll just wait for it to finish executing and see what the result is. So we can see it succeeded, which means it fully executed that Python script, and it just exited out the container, which means that I'm anticipating that a virtual machine instance has been created at this stage. So the way we can check is we can just check our VM instances. And we can see our VM chest ingestion instance has been created, and it was created, let's check the time. So it's like created a minute ago, although the time zone is not reflecting what I have on my clock, but there you go. I still need to get that sorted out. We'll fix the time zones later. And at this point, we need to go into our log explorer because we need to understand what is happening on that virtual machine. Is it pulling the correct Docker image? If it's executing the Docker image, at what stage is it at? What API request is it making? Are the API requests successful or not? We need to see what's going on. So let's go into log explorer. And yeah, let's go into the last 1 minute. And we can see, it's downloading. It downloaded the image into the virtual machine, and it's running. It's running the script. And we can see it's successfully appending data into the chess.com. Sorry, into the chess API GCS bucket. and it's just continuously running, still updating, very rapidly collecting data on all the players on those various months. And let's just take a player name. Let's take Righty1486, and we're going to check in GCS if that data exists. Before we do so, we're just going to shut down our virtual machine, so we're not incurring more cost than necessary. I mean, it costs pennies anyway, so it doesn't really matter. So there we go, we're deleting. And now we can check GCS to see, was that data uploaded into our target bucket? So let's go into Chess API, which is housing all of our request data. So in the player directory, we have Righty1486. Go into the games. We can see in January there's a bit of data coming back, and this data came through a couple minutes ago. And let's just quickly see what's in there. So we got a few games, not too many. You can see that we have successfully requested the data inside that Docker container within the Compute Engine instance, which is pretty cool. And yeah, looking forward to just running it more often for longer day periods and see, how it's pulling back the data for longer time periods, and see if we can get some faults going, maybe. And yeah, hopefully at some point we'll look at improving this pipeline to make the deployment process a bit easier. We need a system that launches a container that's running our jobs, and to get the deployment scripts from GCS. We don't want to be loading our scripts into the Docker image. We want fresh scripts directly from the GCS bucket at the latest state, and that will be the ideal process. And yeah, in the next episode we'll probably take a look at the Terraform configuration and have a look at how the deployments are happening using GitHub Actions. So yeah, that's pretty much it. And I'll see you guys in the next one.